This is soccer, arguably the world's most popular sport. Around 265 million people play the sport worldwide. Behind all of the fun involved in the game, there is quite a bit of science that takes place. The movement of a soccer ball that results from a kick can be explained by physics. When a soccer ball is kicked, the player transfers as much kinetic energy from the foot to the ball as possible. This is called a collision. There are two types of collisions, elastic and inelastic collisions. An elastic collision is where an energy is conserved, like when two billiard balls collide. An inelastic collision is where kinetic energy is not conserved, such as when we kick a soccer ball. The inelastic collision of a soccer ball results in converting kinetic energy into vibrational energy, deforming the ball. The ball then springs back into its initial shape, sending the ball into motion. Both the ball and the kicker's body have less energy after the collision. If this collision results in a ball flying through the air, the ball is regarded as a projectile and will follow the rules of projectile motion. Projectile motion is when an object is launched near the Earth's surface and moves along a curved path under the action of gravity only. Projectile motion can only be accounted for if there is no air resistance, resulting in the horizontal velocity of the ball being constant throughout its flight. In this case, gravity is the only contributing factor to the slowing of the motion. Most of the projectile motion in soccer is known as full path projectile motion. This is when the ball begins and ends at the same height and follows a parabolic pathway. Once the ball is kicked, the vertical velocity is the greatest and the horizontal velocity is also generated. As the ball moves, the vertical velocity decreases due to gravity until the peak is reached where the vertical velocity is 0. The ball then begins to fall and the vertical velocity increases in the opposite direction, mirroring the upward trend as it falls towards the ground. Once the ball reaches the same height as the starting point, the vertical velocity should be the negative of the initial vertical velocity. The horizontal velocity should have been consistent throughout if air resistance was negligible. Since we are not working in ideal conditions, horizontal velocity would slow over time and the overall pathway of the ball would be shorter. It is surprising how much science goes into playing soccer, and many other sports as well. Calculating all of these reactions while playing the game would be nearly impossible. Fortunately, I prefer to relax and just have fun.